Welcome to qnawire.
Hello friends, here it is given a circular plate of mass m is falling with velocity v0 and no angular velocity. When its edge c strikes an obstruction, assuming impact to be perfectly plastic, that is coefficient of restitution to be 0, we have to calculate velocity of center of mass just after impact and impulse on the plate obstruction during the impact. Let us see here. First we will draw its free body diagram. This is the plate. This is centroid z axis, x axis, y axis. So initial momentum is in this direction. Just after impact, mby, mbz, c delta t, mbx, hgx, hgz, hgy. This is r. Using momentum impulse equation. So according to momentum impulse equation, initial momentum impulse is equal to final momentum minus mv naught j cap c delta t j cap is equal to mvx I cap mvy j cap mvz k cap. So from here mvx is equal to 0, that is vx to be 0, mv naught plus c delta t is equal to mvy. So you may write c delta t is equal to mv naught plus by, say equation 1, mvz is equal to 0, that is vz is 0. By the geometry, position vector of c with respect to centroid g will be 1 by root 2 r I cap minus k cap. As we know, collision is perfectly plastic, so E is equal to 0. Since impact is plastic, so we can write so E is 0. E is coefficient of restitution and By will be 0. This is important to note. Now velocity of C can be written as velocity of v plus omega cross rcg. This is vcx I cap, vcz k cap, because vcy is 0, by j cap plus omega x I cap, omega yj cap, omega z k cap cross r upon root 2 I cap minus k cap. On simplifying right hand side, finding the cross product, we can write vcx I cap, vcz k cap, v by j cap plus r by root 2 omega x j cap minus r by root 2 omega y k plus I plus r by root 2. So by coefficient of j cap from left hand side and right hand side, we can write 0 is equal to v by j cap plus r upon root 2 omega x plus omega z. Hence by can be written as minus r by root 2 omega x plus omega z. Now finding moment of momentum. About g, 0 plus rcg cross c delta g j hgx I cap, hgy j cap, hgj k cap. Substituting this position vector of c with respect to centroid g, r by root 2 I minus k cross c delta t j cap I x omega x I cap I by omega y j cap plus I z omega z k cap. Equating the coefficient of I cap, j cap, k cap. So I cap we will write r upon root 2. First find the cross product. Let us simplify this. Then we can equate. So this can be written as r upon root 2 c delta t k plus I 1 by 4 mr square moment of inertia along x-axis of the disk plus mr square by 2 omega by j cap plus mr square by 4 omega z k cap. See equation number 2. Now equating the coefficients of I cap, j cap and k cap, we can write for coefficient of I cap r upon root 2 c delta t to be 1 by 4 mr square omega x, say equation number 3, j cap 0 is equal to half mr square omega y, that is omega y is equal to 0, k cap r upon root 2 c delta t is equal to 1 by 4 mr square omega z is equal to fourth. From equation 1 and 2, c delta t can be written as m v naught minus r upon root 2 omega x plus omega z. So omega x is equal to 2 root 2 v naught by r minus twice of, so you may write 3 omega x plus 2 omega z 2 root 2 v naught by r, say equation number 5, and omega z can be written as 2 root 2 v naught by r minus 2 omega x plus omega z. So you will write 2 omega x 3 omega z 2 root 2 v naught by r. Solving equation 5 and 6, you will get omega x to be equal to omega y 2 root 2 by 5 v naught by r. So from equation 2 we can write by to be minus r by root 2 omega x plus omega z, substituting the value of omega x and omega y, 2 root 2 by 5 v naught by r plus 2 root 2 v naught by r 5r. We will get by to be minus 4 by 5 r naught. So velocity can be written as minus 4 by 5 r naught j cap. So just after the impact, velocity of centroid is minus 4 by 5 r naught, sorry, v naught into z. I have to make a correction here, v naught, and here also v naught. Now impulse from equation 1, c into delta t is equal to m v naught minus 4 by 5 v naught So C delta T having the value. So this is the answer of B part of this problem. Thanks for watching it.